Hey, this is 9-3 graphing y equals ax squared plus bx plus c. The graphs of any quadratic function with the equation that we just described, where a doesn't equal 0, is a parabola whose vertex can be found from the values of a, b, and c. At the beginning of the lesson, it talks about breaking distance, and I thought that this might be a little bit interesting to take a look at. There's a braking simulator, and the link was given in the opening. It's right there. So you can come in and take a look at it. What this allows you to do is to change your speeds and see how quickly you can brake and what the braking distance is. So you press start, and as soon as you see the car, press stop, and you got your braking distance. Now, there's a training effect to this. As you do it, your reaction time gets better. So do it a little bit and then evaluate what happens as you increase the speed. So I'm at 35. Let's see what happens when I'm going 80. And it took a bit longer to stop, and the reaction time had had an impact. So that's there to kind of fool with, just to help show you a little bit about what that is like. Let's get on with the lesson. Okay, example 1. Graphing f of x equals 2x squared plus x minus 15. Use a window big enough to show what's going to happen. So we're going to go into our graphing calculator. I'm going to select graph. I got f of 2 of x, and I'm going to have 2 times x squared plus x minus 15. Okay, enter. Here's our graph. I'd like to be able to see everything in here as clearly as possible, so I need to bring it up so I can see the vertex. I know it's down below the graph because this opens up, and I wouldn't mind tightening it up a little bit. So window settings, I'm going to make my window -6 and 6. I like it to be kind of symmetric. And I think my y minimum, I'm going to leave y max alone. Y minimum, I'm going to make that a -16. And we'll say OK. Now the reason I made it a -16 is I knew that the y-intercept, which we're going to be asked about, but I know that that's -15 because that's when x is 0. And I was anticipating the vertex is going to be close to that. So there's our graph. Here's our window. We can see both x-intercepts, and we can see the y-intercept. For the graph. Okay, I'm just puzzled by the scale. I got it now. Now we're being asked to estimate the vertex, x-intercepts, and y-intercepts. Well, an estimate of the vertex is it's almost at 0,15. It's pretty close, and so as an estimate, we could go with that as our estimate and say that the vertex is approximately 0, -15. The x-intercepts are, and let's see, since this is 6, our scale is by a half. That's 1, 2, 3. So that's -3 is one of the x-intercepts, and then 1, 2.5, and 2.5 is the other one. So x-intercepts are -3 and 2.5, and then our y-intercept, we know that is 0 negative 15. We get that from the equation. So that's using the equation to find the intercepts and to estimate the vertex. Now let's move on to our next problem. And this asks us to find the exact location of the vertex of the parabola that is the graph that we just used. And so here's our graph again, not quite like the one we had. We'll take a look at that one. So we're being asked to find an exact value. And to find an exact value, we can use a table of results, use the idea of symmetry of the axes to find where the vertex has to be. It'll have to be halfway in between two x values. So we've got our graph, got your calculator. I'm going to go to Menu, Table, and it's Split Screen Table. Well, I've got a table here, and if I go up and down and I look for any kind of a repetition, I'm not really going to see it. I have some sort of skips in this thing. I went down from negative 1 to negative 2. I went from negative 14 to negative 9, and I'd like to find a negative 12 perhaps. So I'm going to go back into Menu, go to Table, and edit table settings. Table start is at negative 3. I'm good with that. Table step is 1.0. I'm not good with that. I think I'm going to go with 1/10, so 0.1. And I'm going to click OK. Now I'm going to scroll back down and look for that point where I seem to have very similar results. And there I've got at a negative 1.5 I have a negative 12, and at a negative, at 1 I have negative 12. So what I got out of this table is that at a negative 1.5 for x, that y was negative 12, and for x is 1, y is negative 12. Well, this is what I'm looking for. These two y values are the same. This is a horizontal line, and where that horizontal line crosses the parabola is at negative 1 and 1. Well, if I find the distance between them, and that's 1 minus a negative 1.5, which is equal to 1 plus 1, which is 2.5, right? So that's the distance between those points. Half of the distance is 2.5 divided by 2 is equal to 1.25. So the vertex is going to be either 1 minus 1.25 or a negative 1.5 plus 1.25. And in either case, if I have 1 minus 1.25, that equals a negative 0.25. So our x coordinate is at negative 0.25. The next thing we need to do is to find out what's y, if that's the case, and that's simply plugging it into our equation, where we would have, let's see, and doing the calculation, that puts us where the y coordinate is a negative 15.125. So our coordinates, exact coordinates for the vertex, are negative 0.25, negative 15.125, and that's our solution. So the key to doing this was to find the distance between the 2 points, take half of that distance and subtract it from one of the points or add it to the other point, depending on which way we were going. That gave us our x coordinate. Once we had our x coordinate, we could calculate our y coordinate. and move on ahead. And let me rewrite this real quick in a slightly better fashion. 0.25 and a negative 15.125. That was our solution. Okay, hope I didn't confuse you too much on that one. Let's get on to our next problem. And this takes us to the activity 2 on page 540. I think I'm skipping something here. Oh, activity 1 wanted us to do some graphing. Let's go take a look at our calculator again. We're going to want to pull up a new graphing screen, so I'm going to go right back to the beginning, f of 3, and it asks us to graph y equals 2x squared. And y equals 2x squared minus 10. So menu, graph entry edit, function. And enter. Now we have some questions about it. It asks you to graph it on the same axes. We need to shift this up a little bit, and I'll go ahead and pull it up so we can see what's going on. And we can see that the y-intercept of the first equation, f sub 3, is 0. It goes through 0, 0. That's the vertex. And the y-intercept for 2x squared minus 10 is at negative 10. It asks you then to describe how the two graphs are related to each other. When you talk about the graphs, you're going to talk about them, in this case they open up, so they're related by they both open up. The only thing that really is different here, they are identical except that the vertex has moved down 10. So it's 10 units below the original 2 times x squared. That would give you your answer for that first part. Now let's go to step 2, and it's asking us to graph a slightly different problem. So I'm going to go back in here and create get a new graph, f sub 5, so I have a negative 0.75 times x squared, and we graph that. Menu, graph entry edit, function, and I have now a negative 0.75 times x squared plus 1. What do you think is going to happen to the graph when I hit enter? What will the new graph look like? Yeah, right. It just shifted up 1. It went up by plus 1. It moved the vertex 1 unit up. So in describing the graphs, we can say it's up 1 from the other one. So it asks you for step 3 to graph y equals 2x squared plus c for 3 different values of c with at least one of these values negative. Give the equations you graph and what is the effect of c on the graph. So you should be able to discuss that with me when you come to class. Okay, let's take a look at activity 2. I know you might be a little tired of working with the calculator, so I'm going to show you an emulator. You can get to these online. It's at this website is one. There are many if you look for quadratic equation emulators. Some are better than others. In this case, we'll make use of this one. So here's our quadratic equation graphing emulator. It's asking us to input some values for this equation of x squared plus bx minus 4. So this should be a negative 4. And that's, 2 is the first number, right? So 2x squared. Okay. And first question is what is the vertex? The vertex looks to be at -1, -5. The y-intercept of the parabola, well, we know that just from the equation, is -4. And the x-intercepts are a little bit tougher. We can approximate them. You can see that I can move the cursor on the screen, I can point at it, and I can get a sense that it's about a -3.2, 1.26, thereabouts. So we can pick up the values from the graph. So go ahead and finish the table for the other two values of b. And it asks what features of the graph, this is part B, does the value of b affect? Well, what happens when we change b? Here, I'm just going to change it and we can see what happens. Is b has the effect of moving the vertex. And it also changes the x-intercept, so we're moving that graph around. What feature of the graph is not affected by b? Well, let's move it again and see what stays the same. Of the things we talked about, the thing that stays the same is the y-intercept remains the same. So no matter what we do to it, it continues to have the same y-intercept. The next one, it asks us to find a window that shows a graph of 1/2 x squared minus 6x plus 4. Describe your window. Use the trace feature of the calculate to estimate or determine the vertex, the y-intercept, and the x-intercepts, and tell how they are related. So go ahead and work through that, and then we'll see you at the end of this. You can use the emulator or get back to your calculator and try it there.